Hello everyone, and welcome to yet another webinar session organized by Fogwing team. We really appreciate and thank everyone for taking the time and joining us in this webinar session. My name is Bobin, and I am part of marketing team at Fogwing. So, a quick brief on today's topic, which is asset reliability management. So, we will be discussing about 5 principles of asset reliability management, proactive maintenance strategies for enhanced reliability, IoT data-driven decision making in asset management, some techniques with Gen AI support, and also some case studies with some real-world scenarios. So that will be the topic and for discussion today. For those who have been part of a previous webinar, we are glad to have you back. And for those who are joining us for the first time, let me take a moment to give you a quick intro about us. So we are a Fogwing, leading provider of industrial software solutions for Industry 4.0 or industrial transformation. Fogwing is an industrial cloud which offers a wide range of digital transformation solutions tailored mainly for manufacturing companies by leveraging IoT and AI technologies. So also Fogwing consists of a wide range of product offerings. So let me take you through all our product offerings. Starting with the Fogwing IIoT platform, it's a platform which enables seamless connectivity with machines and assets, facilitating efficient data aggregation. So next comes the Fogwing Asset Plus, Smart cmms, which is a comprehensive maintenance management software powered by IoT and AI. This is specially designed for asset reliability and maintenance operations. So today we will be seeing a small demo of this application. And on to the next one, which is Fogwing Matrix, which is a production monitoring solution, which is for effortlessly machine monitoring, downtime tracking, and OE optimization, etc. Then next is Fogwing Vision, which is a smart quality check solution for automated quality scanning of finished goods using computer vision and machine learning techniques. And additionally, we offer Fogwing Eco, which is an air pollution monitoring solution that includes both hardware devices and software for mainly for industrial pollution. And also, we have been assisting numerous medium, large enterprises in their journey towards adopting Industry 4.0 and digitizing their manufacturing operations. And also, with the global presence, we operate in India, US, Europe, and almost all part of the world through our partner network. So Mr. Hariharan Ganesh, who is the founder and chief architect of Fogwing, will be presenting this webinar. So before getting started, a quick note to all of you. If you have any questions, do not hesitate to ask. You can always shoot your questions or queries in the chat box, which will be answered towards the end of this webinar in the Q&A session. And also, a recorded session of this webinar will be uploaded soon on our Fogwing YouTube channel. And for those who are watching this as a recorded session, you can also post your queries in the comment section below this video. So we will be answering them all. So that's it. Without further delay, let me hand over to Mr. Hari. Hari, over to you.
Hello everyone. Good morning, good evening, good afternoon, wherever you are watching or where you are connected today. So today, we wanted to talk about asset reliability management. And before we take into the particular topic and discuss about the 5 key pillars of principles on the asset maintenance, we wanted to take some step in looking at the reality on what is happening across industry. So according to ISA, the International Society of Automation, and they published a matrix which indicates that there is a significant cost and time and effort are wasted because of unreliable asset due to asset downtime. So considering the downtime as a key factor for the reliability, and the effort estimated around 3.3 million hours a year has been lost due to lack of machine availability, and that leads into the cost around 860. I'm sorry, back. That leads into the $864 billion in total downtime cost, operational cost lost to the Fortune companies. This is not, it's just a metrics of Fortune, but if you consider, the mid-sized companies, these numbers will be going 3 times higher. When we look at it in deep in terms of cost of downtime across, different sectors within the industrial categories, the number one or the top impacted market is the automotive industry, where the downtime cost of downtime is more, is on 20% of the total revenue the manufacturers generating out of these assets. So 20% lost is significant cost for the low margin manufacturing operations. The second largest is the heavy industry, heavy metal industry, where 18% of downtime loss on that. These numbers are significant, and it's of course it's a 2 years back number, but now this numbers could go even higher as more and more plant and operations extending to the global scale. So this clearly indicating that there are a lot of time and effort or cost is being lost while operating the manufacturing setup due to the downtime. I mean, say that downtime, machine is not available for any production action. That means the efficiency has been reduced, the availability reduced, the productivity reduced, and obviously the cost, the revenue generation also reduced. So it's a double fold of the effort, cost that being lost on this due to this downtime. So I know when you talk about downtime, or that's obviously we are talking about the context of reliability, right? How reliable these assets are. Now, when we are running a plant setup and we are operating 24/7, how much reliable these machines, so that we can continue to plan and execute our production operations, scale the business, accommodate more customers, and leveraging the existing investment itself to deliver the product and solutions that we are intended to manufacture. So in that case, there are three primary aspects that we need to look at. When you say reliability, how reliable it is, right? The number one criteria for that is the availability. First, the asset should be available. It should not be down, or it should not be like a fault condition. It should always be available for productivity. So availability is the primary fact that we need to look at. So the percentage of machine availability is very, very critical, especially expected to be a 24/7 availability for operational usage. Okay, then availability is ensure, yeah, the machines are newer machines, it's still available. Then again, second one is more into the performance. How productively we are using these machines, how effectively we are using these machines, and planning and running these machines into to make more efficient product output. How do we are planning and executing it? So that's very important. So the productivity is very important. Third factor is the cost. The cost of operations. Because we want to make sure machine should be available and run, we cannot put too much maintenance activities. So too much maintenance activity leads into too much spending on that, and that leads into total cost of ownership. High cost of operations. Obviously, that will also impact the revenue and the margin percentage on that. So the three key areas are availability, performance, and how we can reduce the maintenance operational cost, so that that we are running in a low operational cost and earning high output and margin on this. So now when we look at this aspect, there are we need to understand how we can achieve this, right? How we make sure that high availability, high productivity or performance, and a lower operational cost. And that comes into the principles, what kind of principle we should follow that. How do we make sure we are achieving the goal of all of three together for high reliability? To achieve high reliability, we based on our discussion, our research, our exploration with multiple manufacturers and various different sectors, we arrived at 5 key points that we should think about when we are looking at reliability management. Number one is proactiveness. How effectively, proactively we are acting to that. Not reactive, but more proactive. How proactively we do the maintenance operations to make sure increasing the reliability level. How we are driving the maintenance operation. Is it like randomly we are doing it, or is it more on because it's a proactive, we cannot do that randomly. So it should be more on data driven or risk driven. So how do we identify the risk factors and then do that? If the machine is going to go down, then we need to do the maintenance. We should not do like repetitive maintenance, because obviously that will increase the cost of operations. So we need to do risk based maintenance. Third one is the improvement. It's not just about maintenance, doing regular maintenance or identifying the risk and then doing maintenance. How efficiently we do the maintenance is also a factor here. So continuous improvement in our maintenance operations, how efficiently the team following the instruction and doing the efficient in the maintenance, that is also contributing to the reliability of the asset. Then the fourth one is, how do we extend the life of the machines? How do we extend the life of the parts that we are using to replace the machine failures? So the parts availability, part life cycle, or even the asset life cycle is important. So how do we extend the life of the asset? By efficiently doing parts, so that we are lowering the parts or asset failure cost on that. The fifth one is the collaboration. So to do all of this, there should be an effective communication within the maintenance practice. How efficiently we can communicate, how we look at the data, how we look at the informations, how do we intelligently think, and do the execute the maintenance operations. That also contributes to the reliability level. So to increase the reliability, to increase the efficiency of the assets, and make the asset reliability level higher, we need to follow at least 5 principles that we have identified here. And we are today in this session, we are going to go through each one of them one by one and understand how technology play a role here to help us to follow these principles. So the first principle is proactive maintenance. So traditionally, we follow the preventive maintenance. We do the pre-scheduling based on the machine, and then the type of machine, and the type of failures happening in the previous history. We try to put the scheduling a preventive maintenance. So preventive maintenance is more schedule based. It's not based on whether the machine is running or machine is used or any problem in the machine. It is more of scheduling. Yeah, this is one of the practice that we have been following, but we should continue to follow that. But at the same time, we should also have the predictive maintenance aspect, because we don't want to do proactive maintenance without any need of that. So we may need to identify the risk factors, and based on the risk, we need to do that. So, or identify predict the timeline when the machine could go failure, and before that or the previous schedule, we need to do that. It's kind of preventive, but at the same time, it is based on the data that's driving the preventive maintenance. So predictive maintenance is driven by the data. So we need to collect the data from the machine, understand the machine's health condition, understand the machine's or assets performance conditions, and then arriving at when this particular asset or machine required maintenance activities. The third one is the prescriptive maintenance. Based on the data that we gather, based on the information, based on the condition of the machines, what type of or what kind of maintenance activity should be done. That is the prescriptive maintenance, which recommends recommends a certain type of performance task or the maintenance task based on the data that we collect from the machines. So fundamentally, data is important. Either you do preventive or predictive or prescriptive maintenance, or if you are following all three of them, which is very, very important for the proactive maintenance. And in that case, the data is very, very important. The data that we collect from the assets is very, very important. And how do we collect the data from the assets? The technology that available today for collecting the data is through IoT integrations. We need to connect to the machine. We have to start collecting how the machine is running, how long it's running, how efficiently it's running, what are the key health parameters that we should capture from the machines, and then analyzing those data to identify the prediction level or identify the prescriptive maintenance aspect of that, or even planning for prevention. We need history data to do the preventive maintenance. We cannot just randomly buy a new machine and then put every 2 weeks once the maintenance. It's not necessary, maybe, may not be, right? We don't know that. So we should have to have the history of data. So all of them should be important. So data collection from the asset is the foundation here to enforce this kind of a practice in place. The second principle is risk-based maintenance. So when you say risk-based maintenance, obviously we need to understand, what is that health, the condition of the missions. Condition of the mission or the asset is critical to identify whether, are we doing the right level of maintenance. The preventive may be helping to prevent certain things, but even based on the usage, based on the type of, usage, the mission health condition could vary from time to time, and we need to identify that. So condition monitoring is part of that, is important. So understanding the condition of the machine while it's operating, while a particular product is being produced, how the machine is reacting, whether other products, suppose if it is, let's take, hard metal product based on brass metal products, machine may be running a little more higher because of the density of the brass metals. Whereas, if it is making a plastic based materials, then it might be lighter, may not be that, stronger, pistons or pressing machine has to happen. So it may be more lighter performance. So the performance of the machine or the machine condition based on different time and the material that it makes. So we have to understand the condition of the machine to arrive the risk factors of that. And then based on this data, we need to identify what causing the machine, what could cause the machine to go into failure, and how do we identify the root cause of that. When there is an equipment failure, we need to go dig through the data and identify why the machine is failing there and what happened to the machine. We need to look at previous machine performance, the material being produced, the operator's operating information, how the energy consumption, energy data, or the vibration data, other data. So we need to look at all of them. So identifying the root cause of that is also considered as part of the risk that we are anticipating, and based on that, we need to plan and execute. Again, for this also, we need the data from the system. So obviously, IoT and IoT integration with the asset and advanced analytics, data analytics, help us to identify which condition the machine need, identify the risk factors to understand why the machine is behaving like this, and what is causing the machine to go in failure. Then the third principles. Okay, so we have done the data collection. We have collected the data. We are gathering information. We are doing predictive maintenance. We are planning and executing preventive also. We have the data of condition data. We are able to see that how the machine is performing, and we also have done some kind of a root cause analysis to identify some of the level. So is that sufficient? No, right? So now how do you react to that, right? I mean, how do you, and what is the reaction to that point? So you have the data, you have the information, but how do you go and do the activities that make sure these kind of risk factors are mitigated, right? So for that, we need to check, we need to enforce certain kind of process in place for maintenance engineer to follow that, because maintenance engineers knowledge vary based on that experience, and a different person may have different knowledge and different assets. So second, sorry, having a I'm sorry, having a common knowledge is not going to help. So we need to have more specific knowledge. And how do we enforce it? That's required a checklist enforcement. So checklist enforcement is basically in following certain guidelines to do the effective maintenance operation. So checklist enforcement is very important for continuous improvement. And then gathering information after post maintenance, whether the maintenance activity has been done properly, what is the activities done by the engineer, or and how they have conducted the operation, what the different things they have conducted. We need to have that summary report. So maintenance summary, and that should be reviewed on a periodic basis to ensure that the checklist is enforced, and this is the team following that information, and that history of the maintenance will help for the next set of team to come and do the maintenance. So how do we create these informations? Do we need to do manually creating all this information, or shall we do like how do we write it, these kind of summary reports? It's very manual effort, right? So now for this kind of scenarios, we have a technology today. We should leverage generative AI and the LLM model, the large language model, to build these context, the maintenance context, the checklist, the summary reports. We need to build those things to to automate those things generation without manually entering it, so that we can reduce time and effort on that. So we can leverage this technology to create summary report and and validate the checklist enforcement on the maintenance operation. Fourth principle, life cycle management. So now we are managing it. We have the data. We are able to identify the risk factors. We are doing a kind of proactive maintenance. We also have the maintenance checklist. We enforce the checklist. We also enforce the summary report, and we are able to analyze all this information. But we also need to understand how long we can do this, right? So we can continuously do that. Is it a lifetime we can do that? What is the lifetime of the particular parts, or what is the lifetime of the particular asset? How long we do that? Because lifetime of the machine or the parts is also a contributor to the risk factors. How long the machine is capable of running the same efficiency. So we need a history data about the machine, past maintenance activities, what kind of repairs happen in the past, how frequently these repairs are happening. So we need a maintenance history, and we should capture that and put it in a more accessible environment, so that we can easily analyze this history of the activities to understand how long the machine is being used. Example, a particular pumping station maybe should be running for 10 years continuously without any issues, or with a minimum level of maintenance. Beyond the 10 years of lifetime, it might need more maintenance activities. So the history helps, the condition helps to understand what is the timeline it is now and how long this can go further. So we need to look at the history of the data. We also need to look at the usage level, because the lifetime can be measured by usage level. So not just the health parameter, usage parameter also is very, very important to track the machine life or parts life. And what is the warranty, that availability? Because warranty is very critical for asset reliability, and how long the warranty is available, when we should renew the warranty, how this warranty, in line with the maintenance machine usage on that. How long the machine is being used, whether it's covering warranty or beyond warranty. Sometimes the warranty class may say that, like, typical, when you're buying a car, they say that, either you should do your first maintenance within 500 miles, or you may do your maintenance beyond that. So you need to look at the warranty period of that, and then identify whether the usage is going in line with the warranty period, or is it something we need to realign the warranty classes to make sure it's happening. So for that also we need information, and that information should be accessible quickly and easily in one place. So for that we need kind of a software systems to capture the history of the maintenance. We cannot use the papers. We cannot use the Excel sheets it's very hard to search in Excel sheet. We cannot use a whiteboarding or boarding system to follow that. We may not be able to use the job cards also, because job cards are like, paper based, and this could be thrown away, papers. So we may not be able to use those things. We need a system with a long, where it can be stored years and years of data, so that we can analyze this data. So we need a software system on that. So typically there's the CMS software system, along with the IoT capability for understanding the mission, productivity, usage, health condition, and things like that. And we need a storage environment for warranty class storage and other things. So we need a software system that could support to store the history, could store the usage information, also the warranty related activities, or the alerts and triggers and things like that. So we need to have a system in place to manage all of them. So that's a fourth principle, and the technology available today. The fifth one is collaboration. Okay, so of course everything is done, but in a competitive world, the availability of workforce is is a big challenge for every manufacturing or any industrial organization. So so knowledge management is very, very critical in terms of how do we maintain this practice, practice across different people coming at different time of the year. It's not guaranteed, like, a maintenance engineer will work for the entire life in the same organization for the same asset related maintenance. And there may be a new people coming. How do we carry forward this knowledge and practice to the new people who are all joining this? How the company, let's say, a manufacturer setting up a new plant and adding a new team. How do we carry forward the practice that we are already following in one of the plant to the new plant, so that the efficiency is carry forward to the new plant as well? So for that, we need a knowledge management repository. So we need to capture all this information. We need to put together a system of procedure, training materials, and other things. We should share this information to the next level of team coming. train them into the new practices. For that, we need to establish the central of excellence, the maintenance excellence. So where we need to carry forward all this information, training process, and that. And between the team also, people are available in the shift basis. Between them there should be a communication. Sometimes some maintenance may take a longer time to complete. Maybe it's going through 2 3 days. There may be a different shift, different people are coming and working on that, who has done in the previous shift, especially a particular machine installation or configuration. If the previous shift people have done and worked to some level, the next shift people are coming and carrying that. They should know that what has done in the previous shift. They need that information. So typically, it cannot be like, paper based, handwritten and things like that. It is very hard to, carry that knowledge to the next level. So we need some kind of system between the team, to collaborate each other. There should be a communication channel between them, how they can share the information between different team working on in the maintenance operations. So team communication is very, very important. And then data accessibility. The data that we gather, whether it's a knowledge data, a specification, or the condition data, or the communication data, right? So everything should be accessible instantly to the team. And they cannot run behind, going to somewhere, waiting for data from somebody coming and giving a job card sheet or history data sheets. They cannot wait for that, because the data is very, very important, and timely availability of the data to the people who really doing the engineering work. They should have this access. So getting this data to their hands is very, very important. So data accessibility is very important process in place for the better collaboration. For enforcing all the three of them, we need a technology solution. And for that, there is a technology available for maintaining the document repository where all the specifications are maintained. Also, there is a technology for common data exchange, such as chatbot or chat work, or using a mobile app solution to quickly access the data and understand what has happened, the history information, the specifications. So all of them should be instantly accessible to them. So we have a mobile technology, we have a data document repository, we have the communication technology available today, and combined together, we need to build the system, the technology that we should adopt, help us to make the collaboration much easier and faster. So we looked at 5 principles so far. But how do you put together as a strategy, right? So how do you put together as a strategy? What are the different things that we should primarily consider? Especially when today we are talking about reliability management and reliability centered maintenance operations. And this required a 360 view approach. We should do everything. We may not able to ignore one or other to say that I only follow this because then my reliability is not improving. It doesn't make sense. You need to have all the aspect of that and understand the 360 view of operation to ensure the high reliability or increasing your asset reliability and availability for the productivity. So to put together, so we need a preventive maintenance. We continue to follow the practice. We should do that, and it should be in line with our maintenance schedules. We also should think about predictive maintenance and building the solution around that, and then making sure we have gathering the data. Even preventive should be based on the data sets that we gather from the machine, and obviously the condition of the machine, not just a asset health, but also the operating conditions that we should capture it, and we should enforce the checklist. We should also have a summary feedback, input from the team on how they have performed it and what could be the next one. Sometimes maintenance engineers comes and say that, hey, I fixed this problem, but I'm doubtful on the rubber valve. It could break anytime. We need to replace it. It is very flimsy, or it's already see that damages on that. Like that, there may be some kind of a next action items that should come from the previous maintenance engineer. So the summary report or feedback is important. Root cause analysis is critical to understand how things are happening, why happened, and what happened. Performance data is very important. Team collaboration, we looked at that, why it is very important. Team collaboration. Knowledge management is very, very, very critical. And most out of all, all this data should be available to the people. So all of them are required. So we identified 10 key areas. The strategy should include these areas as part of their maintenance, improvement and efficiency management that we called as a reliability centered maintenance. most reliabilities around reliability aspect of that. So all the aspect of that should be covered. So we discussed about key some of the things, but one of the primary feeder to this is the data that comes from the machine. The machine should speak. So we typically call it as a your machine speak, you are not listening. So the machine speaks. So we should listen. How do we listen to that? By using sensors. After using sensors, how do we? Okay, we put the sensor into that. The sensors are showing it, but it may be showing in the machine level. Even today, there are sensors are there as part of your machine itself to indicate what is that oil level, what is that vibration level, what is that power current current usage, loudness, noise level. You could have this sensor in your equipments, but are these sensors as transmitting the data to somewhere for us to capture and continuously looking at that, or do we need to capture it in a write up like hourly once and like that? So we need to have this sensors data captured. So for that we should have some kind of a IoT solution which capture this data from the machine, and that sends this data into the some kind of a processing environment where it gets processed, and then the risk factors identified. So IoT is the foundation. IoT technology works like this. It works with the sensors, gather the data, transmit the data to the central processing unit, probably on the cloud, where it gets processed. And then these data sets are identifying the key metrics, the metrics that we need for proactive, the metrics that we need for health monitoring, the metrics that we need to understand for the usage level, the metrics that we need to understand, the root cause analysis aspect of that. And all of them, we need to transfer that into the system, and this data set should be accessible to the operating team and at any time anywhere. So to put together we need to have a system software and the IoT solution combined together to to follow all these operations. So IoT is the foundation for any reliability management, efficient reliability management. And today we are going to talk about how Fogwing Asset Plus is going to play in this role. Okay, so before we go into Fogwing, I will talk about Fogwing Asset Plus, how it can help you in different scale. So today I'm the key things we need to understand is are the top practices that we should have today as a best practices. So we start and leveraging the IoT and connectivity technology, implement predictive maintenance to identify the failures, or predictor failure based maintenance operation, and utilizing the software systems which has a document repository, history tracking, and things like that, so we can plan and execute the task as well as the data get history of the information gets stored and managed as a common repository. And then empowering them maintenance team with the knowledge on in the corrective actions, preventive actions, and the checklist enforcement, or giving their information to more and more by motivating them, train them to efficiently work on the asset operations or maintenance operations. So at least four of them are very important best practice that we should start adapting today itself to reduce the cost of downtime and increase the productivity, helping the organization to improve their revenue scale. Now coming into this is where we comes into picture. We have a solution that fulfill all these needs, and we carefully crafted our solutions to address the to the reliability aspect of that, 360 view of the asset aspect of that. So Farming Asset Plus is a software with embedded with IoT and AI capabilities, which supports three different aspects of that. One is general asset maintenance management in terms of planning and executing work orders and assigning work orders, tracking work history, tracking the maintenance history, enforcing checklist, enforcing summary reports, and gathering all these informations is a basic foundation level. We also helps in proactive maintenance using the embedded IoT technology, using which we also have hardware components or the IoT devices and sensors which we retrofit into the machines to get the data, so using which we can do the proactive maintenance by preventing condition-based or predictable maintenance. So we can drive all these different type of maintenance activity based on the data that gathering from the machines, and Fogwing Asset Plus system supports it. Not only that, it also helps us to get the metrics and data for root cause analysis, or business reports, which helps to understand how efficiently the operation happens, how efficiently the maintenance happens, and what kind of a maintenance improvement, what kind of other improvement areas that we need to work on. So for that, we need the reports and metrics and reports, and that's also part of the applications. This is a key area. But if we go in detail, what level platform is supporting, our application supporting. So we can give the complete modules here. This is a comprehensive solution which supports both CMS solution as well as the asset reliability management or reliability centric maintenance operation. So the modules includes asset management, work order management, and related to assets, and how proactive maintenance either is a preventive or condition based or predictable, and work history, tracking the history of that, summary of the work history for knowledge management, enforcing checklist with the help of AI based checklist, which helps to bring the global maintenance knowledge into the hand of your maintenance engineer to start following some best practices when they do their maintenance task, and allowing them to manage the parts and parts management, parts inventory management, allowing your customers or internal or external customers to to give the feedback, to reach to you and get them access to the system using a customer portal and customer management system. Also helping them to raise a request, getting a request from the users on the real time to capture the demands and forecast what kind of demands are coming through maintenance request, understanding each and every problem happening in the assets, and how do we capture these problems, how do we categorize this, how do we build a report and shows that which are the top 5 faults happening in the system. So for that we should understand how the fault management using fault codes. So fault code feature, IoT based metering feature to gather the data from the machines using sensors. So how do we build the connectivity with the machines? How do we establish a connection? How do we gather that using metering? We can also do manual metering. How do we increase the efficiency of or make sure that the parts are available on time to raise the purchase request to a department, to procurement department, to get the products or parts on place on time, so that we are not delaying any asset related fixes or maintenance operation due to lack of parts availability. That's one of the biggest challenge in any maintenance operations. The parts availability is very, very critical to complete the maintenance process. Otherwise, that itself will delay the overall efficiency. And obviously in the user management, the metrics and things like that. So we also have inbuilt AI solution that helps to capture the summary, helps to capture the work checklist, and also helping the operation team. So we, in addition to that, we also have the mobile app to support the engineers to instantly accessing the work history, previous history, and asset reliability informations, so they can execute the maintenance operation more efficiently. So all of them available in the single system to give the comprehensive functionalities or features to address the and increase the reliability of the system. So before going to the case study, maybe let me take it a step to go and show a couple of key features in our application. I'm not going to spend full time into the application demoing end-to-end of the application, the Fogwing Asset Plus application. It's a very large system, so I'm going to take few things to show it. There are a lot of functionalities are there. The time will not permit us to do that. We have done a lot of webinar in the past. There is a complete demo available in our YouTube channel. If you haven't watched it, go and watch that. That shows the entire capability of the application. Also, we have a different set of data is available in the different set of webinars we conducted in the past for the maintenance operation. If you haven't watched it, please go and watch our YouTube channel where you can see all the previous webinar and related content. So today I'm going to show, how do we create a very important thing, we looked at it from the reliability standpoint is the IoT connectivity. So today I'm going to show how do we do the IoT connectivity in the system. How do we connect my missions to this application so that, we can start getting a, data that's coming from the mission that can be used for prevention. So for that, first thing, you need to have a account with a pro, you have to have a pro account subscription plan to have this IoT feature enabled for you. So here, you can go and in the go to the settings page where you can see the IoT devices. Go here, and I have already pre-configured some set of devices here. And you can see these devices are already pre-configured. Some of them disconnected. So to first time, to establish a connection. So you should have the devices configured in our IoT platform. There is a separate webinar we have conducted. You can look at that on the how do we configure a device in the IoT platform. For me, as of now, for this quick demo, I have pre-configured my IoT access. So click on this. If you go to the IoT provisioning, device provisioning, click on this settings icon where you can see a API key access with our IoT platform. So you can just give your IoT platform access keys here that create a API access for your devices, and that API access should be stored here automatically. I already pre-configured it. Now, you wanted to have, when you do this, automatically it brings all the devices that you already configured in the IoT platform. So in the IoT platform, in Fogwing IoT platform, if you already configure the devices, all the devices will automatically list. You don't need to have add here. It's just bring the devices here. All you have to do that is defining your attributes. When you say attributes is nothing but sensor parameters. So let's take, I want to monitor the current from this particular mission. So I just said that, okay, use the attribute of IoT, right? I mean, attribute of current here. So I configure it. If I want to, check the vibration, right? I just create a vibration because I'm expecting this data coming from the mission. So my vibration level is, let's take, 1000 frequency, and then, I say that it's a vibration data. So I just save it. So when you're getting stored, these data are helpful here. So because connecting these two systems is very important to get this the triggering the preventive maintenance or predictable maintenance. So now it is configured on the device level. So I have a device configured. Now I go to the assets. Go to the assets. In the asset level, you can configure the when you're creating an asset, you need to configure the metering. So in the asset level, let's take, I want to create a pump, okay, as asset. I simply clicked it, and category is type pump type. I have this plant, and metering. I select a metering. Very important. You need to select the metering because it's a meter based on IoT data is based on the metering, and then you save it. Okay, so I need to go here, the metering, and then I need to select it. So here you have two type of metering. One is manually, your engineer can come and enter the data, or you can have IoT based. So in the IoT based, you choose the device. Now you see that I have already selected the oil. I created the vibration just now, the attribute. The purpose why we are creating the sensor parameter to understand which parameter based trigger we should do that. So let's take I want to do that based on the vibration. So it's based on vibration data. And then, I want to create a unit of measurement is frequency. So whenever the vibration data, I'm creating a rule. Whenever vibration is based on more than 600, let's take, this is the condition my machine is going into that issue in pump. So too much vibration. So I'm creating a rule saying that whenever this particular asset and its vibration level exceeds the limit, like a 600 values, then I need a instant, I need a work order to trigger this. So I need a work order to be automatically created. So I'm creating like, okay, it's a medium level. Type of work order is on-demand work order. Maybe I can say this on-demand. And then I'm also enforcing the checklist. So I have a oil pump inspection checklist that I am enforcing it, and I can instantly assigning to a particular team or engineer. Let's take, I'm assigning this particular engineer, and I even predicting this, how much time it takes to look at this issue, maybe 10 hours required to this. So this is how, I configure it. You are not creating work order here. You are basically configuring it. So once you configure this, what happens based on this information, based on this pump, whenever the frequency goes beyond the limit, this automatically creates the work order here. The work order will be appearing in this section as a priority based work order, on demand work order. Okay. So this is how the data should appear. So you need to configure it at the asset level to trigger this. This is one way you can start capturing it. You may set the frequency, you may set it, based on the based on different timeline, your vibration level or average value and things like that. There are a lot of functionalities are there behind this. You can implement it. If you are not sure how to do the IoT connection, there are a lot of webinars we have hosted on how to do the IoT in asset management also. So you can look at that and then you can follow the instructions. If you are still not sure, you need help, you can reach us out and our team will help you on configuring it. Our team will help you on even providing your hardware devices or helping you to configure using your existing hardware devices to connect to the cloud, to the IoT platform, and then work in this system itself. So, but very, very important second most thing is, I wanted to show here is the history, right? So you can see here, some of the history data is here. So we typically capture all the progress of the work progress. So the history will get stored. So when I'm going into the work orders and then I'm looking at the completed work order, let's take now, I look at the closed work order, maybe this work order. So I can see the history of this work order on what happened in this work order and how frequent things are happening. And this data can be used for summary generation using AI technologies. So, so this is very, very quick demo on how things are working, how to configure the IoT, how do we do the metering, and whenever the data comes in, automatically the data gets populated here. So we can quickly show this, see the data populating here as well. So either you can do manual metering or IoT metering. If you are doing manual metering, let's take, you don't have IoT devices, you don't want to try the IoT now, you want to do manually, asking your operators to or machine maintenance engineer to capture the data, and you are already practicing it, you can still do that. You go and select the pump. Let's take, same oil pump. I select it, and then I go and type this. Okay, I think I created a pump, and I go and type the here data. So I have designed it as a IoT base, so it's not enabled here. But if you take a manual entry in the configuration, it allows you to enter here. So you can manually capture each and every stage of the metering. Based on this, also your application can trigger, or your work order can be triggered based on this data itself. So either you are doing manual metering or IoT based metering based on the machine conditions, based on machine usage condition or the health parameter conditions, you can trigger your maintenance. Either it's a preventive maintenance or proactive maintenance. The other module to scheduling preventive maintenance, you also have a scheduling module here to schedule the preventive. So you can go here and then schedule prevention based on your scheduling. It will automatically trigger it. Let's take, I go back to the same pump where I want to do the preventive. So check the oil level. I want to do that as a preventive. Maybe, I put it in a low priority on that and follow the pump checklist. Starting from let's take, starting from next week, from next week, I want this to be happening in a uh, two every weekly basis to make sure it is happening, and every Friday I want this to happen. So we select it and scheduling it. Once you scheduling it, this system automatically triggers. Right now it's in draft stage. As soon as the point triggered when the timeline reached on 17th, today is 14th, December 14th. As soon as it reached the timeline 17th, it automatically triggers it and become a scheduled task. So you can see that it's a scheduled one. So this becomes scheduled one. So automatically every week it will create a work order and then show the next work order available. So as of now, if you see this particular work order, it shows the next scheduling is on December 22nd, and that the work order is a regular inspection, right? So let me go back here and search. Go here. So you can see here, already it's there. So December 22nd for this particular asset, it's a preventive maintenance. It's a open, so it's still open. So we need to execute, and the previous maintenance also is pending. So this is how you can schedule the preventions also to automatically trigger the work order and assign to the engineers and conclude and conduct this. Okay, so that's a quick demo. So let me go back to the presentation and talk about few things before we go to the end of the session. So the case here. So we have applied this approach, the principles in one of our customer who is the largest recycle management company, where they are leveraging Fogwing Asset Plus. So the challenge for them is they have a multiple plant across different region, different things, and they have a centralized maintenance team. And team availability on the particular place on the when is very important, and they cannot allow any downtime, and they conduct extensive preventive tasks, traveling between the places and doing on preventive maintenance activities, extensive preventive maintenance activities. Due to that, there are a lot of financial challenges and extreme expenses on the operating side. So by using our IoT and AI capability along with the Fogwing Asset Plus system, we deployed this to monitor the condition of the baler, conveyor belt, and other assets, and we could predict the data. So the centralized, maintenance team, operation team, sits in the corporate office and monitoring all these, asset performance, asset maintenance activities, and then they are able to predict it, when a particular machine maintenance is required. They are able to understand, when the machine could go fail, and they could reduce the travel time, unnecessary cost of moving from place to place, and shuttling the maintenance engineers between the locations, and they are able to reduce the cost by 100%, and that automatically increase their reliability and efficiency by 100%. So totally 200% value that we have driven out of this exercise, and it is a continuous process. It's not something you can just do one time. Oh, I see the results, and after that you don't need to follow. It's a practice. It's a practice you need to follow continuously and efficiently, and that is why Fogwing Asset Plus maintenance management softwares are important to capture and drive this practice constantly. And the results are very great, and happy to see the customer. They are quite pleased with the solution and the results they are gaining out on this implementation. If you are, I think this is we looked at that. Fogwing is an industrial cloud and offering various softwares, and these are the key softwares we are offering for the manufacturing, for smart manufacturing solutions, which I think we have already seen that before in the beginning of the session. With that, we can go in the Q&A session.
Thank you, Hari, for the deep insights. So we have a few questions. I'll just read out one by them. You can respond to it. So on to the first question. What are the key metrics or indicators that organizations should focus on for effective asset management?
Okay, so key metrics. Okay, so number one is the frequency of maintenance and the effort spent on that. So that is very important. Second thing is asset downtime, availability, and time to repair. So MTT or MTBF is the most important key metrics that they should monitor at real time, and that should be more like proven model. So it should not be like just an entry based system. It should be real time captured system, so data. So the mission starting, mission down, and the time to repair based on the parts availability and things like that should be really important. The fourth one is the efficiency of the maintenance operations, like how efficiently the operation happens. So by capturing the checklist compliances, how much checklist compliances, all fault trend in the system, how much the assets are getting fault, and what is the most frequent fault, and those kind of things are very important metrics to the reliable maintenance.
Okay, thank you, Hari. So on to the next question. How do you make sure that the information collected from assets stays safe and accurate?
Okay, so okay, that's a great question. So number one is obviously IoT based. It's not manually somebody capturing these mission health parameters, manually entering it. So it's IoT based. So obviously the data that's coming from the sensors is what we are capturing without any human intervention. So the data accuracy is there itself. It's more reliable. But at the same time, data captured in the device and that securely transmitted to the repository or centralized system where it is being analyzed properly without any human intervention. Not like somebody importing data and somebody trying to manually running a script to calculate the metrics like that. It's automatically it should be done with the help of a system and software, and that is also very very important, and that obviously we support it in our system itself. And the intelligence, with the help of third party intelligence like generative AI usage, by using a private instance, using generative AI instances helps to securely load the data and then processing the data and get the intelligence out of that. So all of them important. So to put it in a simple format, no human intervention in the whole process end to end, fully systematic approach, and highly reliable cloud infrastructure where the data is secure and processed, and then the metrics are used.
Thank you, Hari. On to the next question. How does Fogwing Asset Plus help with asset reliability management, and what makes it different from the other solutions out there?
Okay, so number one, our system is it's a okay, our system is carefully crafted to address the end-to-end of maintenance operation, like reliability centered. That's a key difference. It's not just a maintenance software. It is not just a IoT solution where only do the predictive maintenance. It is a comprehensive solution centered around reliability, all angle, all 360 view of the asset. So that's a big difference. And the application system is built as a simple no code, no even low configuration system. It's easy for customer to quickly onboard and start using the system with the hardware supported by us, with the sensors and the condition monitoring devices supported by us. So it's a one vendor who provides all the solution together rather than dealing with hardware buying from somebody else, software buying from somebody else. Another company is providing a predictive maintenance to me, and it's my responsibility as a manufacturer to combine together and then see the results. It's very hard for them to do all of them together. So it is not a one piece of portion we are covering. We are covering the 360 view of the maintenance, and it's available on a subscription based model rather than long investment time and cost invested in implementing month and month, and then hosting in on premise which is not accessible outside of that. So this is a more SaaS model, so software subscription model, so low investment, high return value, and quick and faster implementation timeline. All our customers could to apply these practices um, in a week's time rather than in waiting for months of implementation than the traditional maintenance software implementation cycle. And obviously, it's a comprehensive solution with covers end to end of that.
Okay. Thank you, Hari. I think that's all the questions we have. Thank you, Hari, once again for answering all the questions. I hope it was helpful for all those who have asked and for others as well. I think now it's almost time to wind up the webinar. So, as previously stated, we will be uploading this webinar as a recorded session on our Fogwing YouTube channel. So, therefore, you can visit our YouTube channel to watch this webinar and also our previous webinar sessions. And also for those who are interested in gaining any further insights into IIoT, Industry 4.0, smart factories, etc., we encourage you to explore our blog sections at www.fogwing.io/blogs. And also, additionally, if you are seeking any collaboration opportunities, please do not hesitate to contact us at sales@factana.com. Thank you once again for participating in the session and contributing it to its success. We eagerly anticipate connecting with you in our next webinar. So until then, stay tuned and have a wonderful day. Bye.
Thank you, everyone. Have a wonderful day. Bye bye.